Thank you, John, and thank you, everybody. It's a terrific meeting, and is there a clicker, or do I just do it on the button?
Yes, we do have a clicker, so
just in case I wander. There it is.
So feel free to walk around if you talk loud.
Yeah. Okay, yes, but I'll stay with the microphone. Great meeting, wonderful to be here with so many people. And I've called my talk the cultural equivalent of sex. Always get sex in the title if you're a writer, because it helps, gets people's interest. But also, you can look at it, if you like, as an attempt to sort of get the horizontal angle in. We're talking a lot about cultural inheritance and also about, the contrast between groups, etc. But there's horizontal transfer of ideas between groups and between lineages, which is very important, and that's what sex is all about in biological evolution. And I'm making the point that we need to identify the equivalents in cultural evolution. Just to summarize what I'm going to say in advance, so you can know where I'm at. Only human beings cooperate with strangers. That's too strongly put, but it's obviously one of the striking features of human people, of human societies. Lots of animals have culture apart from ourselves: crows, parrots, dolphins, chimps, meerkats, Homo erectus, Homo neanderthalensis. And yet, very few animals seem to have broken out into something called cumulative culture, or as economists call it, economic growth. And we know that to make biological evolution cumulative, you do need to have sex, i.e. you need to have genetic recombination. And I'm making the argument that to make cultural evolution cumulative required the invention of something similar, in particular a form of exchange. I think it's just useful to throw in why I don't particularly think human uniqueness is all about groups. We've heard interesting things about groups and some great ideas, and I think it is important to understand groups. But I was just thinking about this yesterday. I flew across the Atlantic. I took a taxi down town, etc., and I interacted yesterday with a huge number of people, none of whom I knew, and none of whom I'll ever see again, and all of whom did me a favor. They flew my airplane, they checked me in, they drove me in a taxi to Manhattan. I did them a favor too. I handed over some cash. So it was a mutually beneficial relationship. It was pure cooperation. There was no altruism involved. I wasn't being altruistic to them. They weren't being altruistic to me. And yet we both benefited each other. So one of the most unusual features of human beings is their capacity to cooperate across group boundaries as well as within groups. And I think we mustn't lose sight of that fact. Just to run through, Peter's already made this point very well, and it hardly needs repeating, and particularly for this audience, but just some of the examples of why culture clearly is a Darwinian process. And I think Pete and others have established that now to the satisfaction of people who are paying attention, at least. Descent with modification, you can see these wonderful family trees of technologies. Here's a beautiful chart from Pitt Rivers in the 19th century showing the relatedness of different tools used by people in the Pacific. You get convergent evolution, just like you do in Darwinian evolution. Egyptian ancient boomerangs are very similar to modern Australian boomerangs. You get succession and extinction, or as economists call it, creative destruction, which is part of the answer as to how things evolve is not necessarily by them adapting, but by them losing out in competition. And it's clear that an ingredient of Darwinian evolution is variation, that there must be an element of randomness in variation, but as Pete and others have pointed out in a very important paper, I think it doesn't have to be purely random, so you can get trial and error in technologies. Look at the tail planes of early aeroplanes, huge amount of trial and error going on in technology. And the more we look at technological evolution, people like Kevin Kelly and Stephen Johnson and others have made this point very well in books, that actually there's a lot more trial and error going on than we thought about. And when we get a good idea, we replicate it, just like natural selection does. Of course, competition is the decider as to who gets to reproduce. But there's another ingredient of Darwinian evolution that we sometimes, I think, don't pay enough attention to, and that's recombination. The crucial importance of having sexual reproduction so that you transfer and swap genes between lineages in evolution, as I'll show in a minute, is very important. And until recently, there were some troubling exceptions to this. There were animal groups that had showed speciation without having sex, and here's one of them. It's called the Deloid rotifers. There's a number of the speciation has happened in the last 80 million years in this group quite successfully, and yet there hasn't been a male Deloid rotifer on the planet for 80 million years, according to the genetics. So they haven't had sex for 80 million years, and yet they've produced species. How is this? They seem to be a troubling exception to this rule. Well, it turns out they're an exception that proves the rule, because in 2008 it became clear that this is a group that indulges in horizontal gene transfer on a massive scale. That's what bacteria do too. In other words, they pinch genes from animals they eat, if you put it like that way. So in other words, they've developed an alternative to sex. And this idea of horizontal gene transfer, which is particularly important now in understanding bacterial evolution, by the way, where between, the idea of a species no longer quite makes sense in the microbial world, I think is very important, and it produces a nice parallel with what's going on in culture. Why is sex or horizontal gene transfer important in making evolution cumulative? Well, if you think about it in an asexual population, if you get two good mutations in different lineages, they end up in competition with each other. So, for example, an early mammal invents fur, and a competitor invents mammary glands. You've got to decide which you want in the species, because these are going to be in competition to each other, and you end up with one or the other, but you don't end up with both. Whereas in a sexual population, at some point an individual can inherit both, both the mammary glands and the fur, and put them together. And so the point about sex is that it enables individuals to draw upon inventions wherever they happen in the species. You're drawing upon the genetic mutations that can happen anywhere in the world in your own species, because you're connected genetically to all other members of your species. And I make the case that this is very much what's going on in human culture. Here's this picture which I like to show, which of two objects that sit on my desk at home. I suddenly noticed one day they're exactly the same size and shape. One is an Australian hand axe from 500,000 years ago that my wife bought for me on eBay, and the other is, of course, a computer mouse. And what's interesting, the similarity actually between them is trivial. It's boring. It just means they were both designed to fit the human hand, although it is very striking how similar they are in size and shape. But the difference is more interesting. The one on the left is made of a design that was unchanging, as I think you make the point, John, in your chapter. The design of the Australian hand axe didn't change for 1 million years. That's extraordinary in modern terms. It's bizarre to think of a technology that doesn't change for that length of time. And it's made from a single substance and embodies a single idea, and was made by one person. Whereas the object on the right, when you think about it, it's already obsolete. I no longer use it, because I use a laptop instead. But it's made of a combination of different materials, plastic and metal and silicon, but also a combination of different ideas that occurred to different people at different times in different places and came together. So what's key about our modern culture is that it's cumulative. It's able to bring together these ideas that occurred to people who are dead and who lived miles away. They came together in this object. And when you think about it, as Brian Arthur has made this point very well, all our technologies are combinations of other technologies. This is a nice example. It's called the pill camera. It takes a picture of your insides on the way through. It came about after a conversation between a gastroenterologist and a guided missile designer. Now, how does this happen? How do we combine ideas to make other ideas? How do we enable ideas to have sex, as I put it? And the answer is through exchange. This human habit of swapping one thing for another thing is peculiar to human beings, almost unique to human beings. There are examples which I can talk about in question time if you like, but they're mostly between related individuals or mated pairs, things like that. But otherwise, in the animal kingdom, it is very unusual to find animals swapping one thing for a different thing. And as Adam Smith put it, no man ever saw a dog make fair and deliberate exchange of a bone with another dog. I'm not talking about reciprocity. There's a terrible confusion in the anthropological literature between exchange and reciprocity, which I find very difficult to get out from under. And Leda Cosmides and John Tooby have written about this. Reciprocity is swapping a different thing at the same time. I scratch your back now, you scratch my back later. There's plenty of that in the animal kingdom. There's no shortage of that. And there's some of that in human beings, but it's not actually all that big a feature of human society. It is important. What I'm talking about is exchange. We swap different things at the same time rather than the same thing at different times. And that's something that we are obsessed by, and we do much more than other creatures. When did we start doing this, particularly among strangers? When did trade start? We've already heard that conversation, that question this morning. I'm very interested in this question. It's one of the ones I'd like to put on a post-it note because I don't think archaeologists are nearly interested enough in this question. I can't get them excited about sort of trying to identify when it's starting to happen. As John mentioned earlier, the diagnostic feature at the moment of the start of trade is objects moving long distances. And here's one of the examples. It's Nacerius marine snails being used as beads 100 miles inland in Algeria around 80,000 years ago plus, probably up to about 120,000 years ago. Now, that is, snail shells don't move 100 miles inland by migration, they do so by trade. We know that because if you look at modern hunter-gatherer tribes, you see exactly this phenomenon, objects moving long distances through trade. A place called Mount Isa in Australia where the Kalkadoon tribe created these stone axes and they traded them with their neighbours, and as a consequence the area of Australia over which you can find stone axes is far larger than the area occupied by the Kalkadoon tribe. So moving long distances is the diagnostic feature of trade. And as I say, it looks like 100,000 years ago or so. The weird thing is the Neanderthals don't seem to have done this. Now, Neanderthals had huge brains, they had culture, they had language. As far as we can tell, the Foxby2 stuff seems to imply that the null hypothesis is that they probably had language. They seem to have everything going for them. So what's stopping them? Why are they still like dolphins or other creatures? They're simply stuck with one technology. They show very, very slow cultural evolution in terms of their tools. And the answer, I suspect, is because they're not doing exchange between groups. So they're not getting access to a hugely wide possibility of new materials and new ideas. There's a cave in Georgia called the Zudzoana Cave where Neanderthals were living there 30,000 years ago and using only local materials to make their tools. When modern African-derived hominids moved in, about 7% of their tools are from hundreds of miles away, material from hundreds of miles away. Now, the problem with this neat story, which I thought was very exciting, is that about a month ago, I was talking to an archaeologist from Sheffield who's working in this very area with this team, and they've now found evidence of obsidian tools being used 300,000 years ago in the area that have moved up to 90 or 100 kilometers, which is too long for my hypothesis, so bang goes that theory. But it's not a very long distance, and there's only a few of them, so maybe it's all right. But anyway, I think this is a really interesting question, as to when material starts moving long distances. And the point about this is that this idea is it can explain something that actually a lot of other theories, I think, have trouble explaining, which is why when culture gets started, it sometimes then goes backwards. There are good examples of this in Africa. Around 70,000 years ago, you get flowerings of new technologies in southern Africa, around Pinnacle Point and places like this. And what's going on here? Why? And then they disappear again. Why do they disappear? Well, Mark Thomas and his colleagues in London have done a very nice analysis of how this could be simply demographics. If you've got a culture in which the ability to make technology depends on the number of people who are interacting with each other, then if you get an increase in the demography, in the number of people in the area, then you'll get a flowering of technology. And when for climatic reasons or something there are fewer people, then the technology will disappear again. So going forwards and backwards. And of course the classic example of this that Joe Henrik has written about is Tasmania. 10,000 years ago became an island. The people on there not only failed to get hold of technologies that were invented on the Australian mainland after that, like the boomerang, they actually gave up some of the technologies they already had, in particular bone tools. Why? Because there's too few of them to maintain the division of labour to keep these technologies alive. The same thing did not happen on Tierra del Fuego, demographically and geographically very similar, but separated from South America by a much narrower strait with trading contact with South America throughout. And as Rob Boyd and Melanie Klein have shown, Pacific fishing tackle technology shows a phenomenon whereby, if you correct for island size, there is a relationship between the amount of trade an island has and the amount of sophistication of its fishing tackle technology before Western contact. And of course this plays through into modern human history. Basically, if you look around the world at where cultural and technological innovation happens, it happens in areas that are doing an awful lot of trade. So here are 6 great innovators: Archimedes, Al-Khwarizmi, Fibonacci, George Stephenson, Thomas Edison and Steve Jobs. What have they all got in common? Each one was living in a rich trading nation at the time, or trading group of nations, if you like, trading city-states, so ancient Greece, Abbasid Arabia, Renaissance Italy, Victorian England, New Jersey, and California. So, just one final point, really, which is that, of course, the consequence of this is that a collective brain is running our society. It's all about cooperation. It's all about collective intelligence. Because when you think about it, that mouse was made for me by hundreds and millions of other people, including a man brewing coffee in Brazil for the guy on the oil rig who was drilling for oil, whose oil was going to be used to make the plastic. They were all part of this project to make me a computer mouse. They were all working for me. And yet not one of them knew how to make a computer mouse. There's nobody on the planet who knows how to make a computer mouse, because the man in the factory doesn't know how to drill an oil well, and so on. So the knowledge has actually got distributed, and we're capable of doing things that are way beyond our individual intelligence. And of course, the internet has made this collective brain much more spectacularly wired up, and ought to result in a greater rate of innovation. Thank you.